This is the velocity formula that we're going to be using, and it makes sense actually. This is the initial velocity, this is the final velocity, this is acceleration times time. So the sum of acceleration and time and the initial velocity gives you the final velocity. If we think about our units, and this is why it makes sense, if we think about our units, if we have seconds for time, and if we have meters per second squared for acceleration, plus meters per second for initial velocity is equal to meters per second. I'll put an F here so we can distinguish it from that, from I. That's our final velocity. Well, what happens to these S's? That's S to the first. It's going to cancel. And if we do that, if we multiply acceleration and time, we wind up with velocity. So I got rid of one S there, I got rid of one S there. So they're all in the same units, so we can add them together to get the final velocity. And you've probably been wondering what this bus's acceleration has been. It's probably been nagging at you since you watched the last video. Like, I wonder what the acceleration is. Well, you're going to find out. We're going to use this formula, the one I just showed you. V is equal to AT plus U. And we've already defined our initial velocity is 15. Our final velocity is 20. Our acceleration is unknown, so we're going to leave it as A. And our time is 20. Now we just have a little bit of algebra. 5 is equal to 20A. Okay, we have 5/20ths, which is equal to 0.25 meters per second. Sorry, this is getting a little messy. Is equal to A, and that shadow is annoying too. I'm going to try to correct that before I make the next video. But I'm finished with this one.